example, you have here ground profile. So, linear ang ground profile. Then, your road width. So, nasa taas yung mga road width. So, that means this area or this part is need to be filled to accommodate the road above the ground profile. Then the three level section. So you have your ground profile here from this point, and at this point, then at this point. So you have your ground profile in three levels. Then you have your road width here. So that also means that this area or this part is to be excavated. So let's have example problems for this. So the cross-sectional area of the road with width of 10 meters is 26.9 square meters. The cross-sectional data as follows. So you have here data. And then if the side slope is 2 is to 1, what is the value of y? So how you're going to plot this, mag-start ka sa road width. So ingon siya nga ang road width is 10 meters. So you draw a road width of 10 meters. Then you divide them and you draw a center line. So that's CL. Then since center line mo na siya, so the half of that is 5 and the other is also 5. Then you're going to plot these points. So you consider them as x and y distances from your center line and from your road. So this is the road. So 0, so that means ari siya sa center line. And then y. So murag x and y axis ra gud nga distance. So x is 0 and y is y. So muna siya tong gipangita the value of y. So at this point, so kani nga point. Then on the other side, so you have 9.8 and y2. So from CL, that's 9.8, and then from the road Pasaka, that's y2. Y2 pa ha, wala pa ta kay saan siya, y2. So at this point, kanina point. And then on the other side, so you have x and 1.2. So from CL, you have distance of x, and from your road Pasaka, you have 1.2. So this point. After you plot the points, you connect those from dire, one side of the road. So you connect them, connect na mo sila, na connect and connect. So that means these are the areas. This since this is the ground profile, and since Hato ang road is nasa ubos, so that means this area is to be excavated. So okay, so balik ta diri sa atong distances. So you have this distance nga 9.8 at this point, and the road here is 5 meters. So that means you can solve this distance. It's 9.8 minus 5, so that's 4.8. Then this is the slope, the side slope. So the side slope is 2 is to 1. Now, if wala siya gi-specify kung asa ang horizontal and vertical, kung asa ang mas dako, mauna siya ang horizontal for stability. Diba, mas stable siya kung mas lapad siya sa horizontal. Kay mo slide ba ya ang soil. So kung asa ang mas dako, mo to siya ang horizontal. So you have two here horizontal and one vertical. So that is the side slope. So you know the side slope is 2 is to 1 and this is 4.8. So by the ratio 2 is to 1, you can solve for this height, or that is y2. So y2 is 2.4. And on the other side, so you have 1.2 that's given, and the side slope 2 is to 1. So you can solve for this distance with that 2 is to 1 ratio. So this is 2.4. So now you have this 2.4. You can just add 5 plus 2.4. So the distance of x1 is 7.4 meters. So you have the distances, you can solve for the area. So the area is the summation of area n, or those areas. Ato siyang i-divide. For it to be easier to solve for the areas, you divide them. It'll be easier to solve if you have triangles as areas. So you divide that to siya into these four triangles. Okay. So kani one half, igawas na nato siya since common man na siya sa tanan. So area 1, so that's one half 5 times 2.4. Diba? The space times height of this triangle. So that's 5 times 2.4. For area 2, so that is 9.8 times the y. So 9.8y plus area 3. So it's 7.4 and y. So it's 7.4y plus area 4. So that's 5 times 1.2. So 5 times 1.2. So the area is area is 42.9. It's 42.9 square meters. And with that, we can solve for y. So y is 3.94 meters. Okay. Okay, so another example. So find the area in square meters of the given cross section if the width of the road is 12 meters. So you have the given cross sectional distances. So first, again, you draw the road. So the width is 12 meters. So that is a 12-meter road. And then you divide them. You draw a center line. So the half of the road is 6 meters and the other also 6 meters. And then you plot the points from this data. So again, kung asa ng 0, just consider that the center line. And then those are the distances on x axis. And then the tungod niya, parang nasa yung tungod, those are the distances in the y. So first this one, that is 0 and 2.8. So ani, 0 and 2.8. This one, 9.8. So that's an x distance from CL, 9.8. And from the road, Pasaka, that's 3. And then here, so you have 11.2 from here. It's 11.2, and from the road Pasaka 4.89. So that is this point. So again, connect them from one side of the road, connect those points, connect niyo muna sila, and then you close them by connecting its other side. So divide the profile. So this is, so still with this figure, it is soil to be excavated. So you divide them into triangles, or kung say mas easier. So it's easier for this to divide them into triangles to solve for the area. So dividing them into four triangles. So you have area 1, area 2, area 3, and area 4. So area is summation of these areas. Okay, so area is one half for area 1, one half 6 times 3. So it's 6 times 3 plus area 2. So for area 2, that's 9.8 times 2.8. So 9.8 times 2.8 plus area 3. For area 3, that is 2.8 times 11.2, or 11.2 times 2.8, plus area 4, that is 1 half times 6 times 4.89. So that's 6 times 4.89. So the area for this cross section, the area is 53.07 square meters. So another example, a particular station has the following earthwork cross section. So those are the section, data. Then if the width of the road base is 9 meters and the side slopes are, so kanay specify siya, 1 vertical and 1.5 horizontal. Solve for x, y, and the area of cross-section. So again, you first plot the road, so which is 9 meters. And then you divide it by the center line. So that's 4.5 and 4.5. So we plot the points. So asang 0, so that's where the center line is. So 0 and positive 2. So that's these are the distances in x and y. So 0 and 2. So ano siya. Then this side, so let's have the 4.5 and 4. So this point. And then this one is 9 and y. So at this point. Then on the other side, 4.5 and 2. So 4.5 and 2. And this one, x and 1. So x and 1. So after you plot the points, you connect them from the road. So connect those lines. Okay. So after you connect them, you can find the other distances nga kinahanglan. So this is the side slope. So gi-specify niya nga 1 vertical, 1.5 horizontal. So those are on both sides, dire and also dire. 1.5 horizontal and 1 vertical. So first, since this is 9 meters and the road here is 4.5, you can solve for this. That is 9 minus 4.5, so this is 4.5. And with the side slope, that is 1 is to 1.5, you can solve for y. Y is 3. Or here, y is 1 is to 1.5 times 4.5. So y is 3 meters. And here on the other side, given ng vertical nga 1, and you know the ratio of the side slope, so you can solve for this distance. So that is 1.5. So x is just 4.5 plus 1.5. So x is 6 meters. Or here, x is 4.5 plus 1.5 times 1. So that is 6 meters. Then divide them into areas or divide them so it will be easier to solve for the areas. So for this, we divide them into 4 areas: area 1, area 2, area 3, and area 4. Okay, we can solve for area 1. So that's a triangle, 1 half. So that is 4.5 times 4. So 1 half 4.5 times 4. So that's 9 square meters. Area 2, so that is 1 half 4 plus 2 is 4 plus 2 times 4.5. Now that's 13.5 square meters. And area 3, that is just 4.5 times 2. So 4.5 times 2, 9 square meters. And area 4, also 1 half is 1 half 1.5 times 2. So 1.5 times 2 equals 1.5 square meters. So the area of this section, that's the summation of all these areas. So total is 33 square meters. Okay, so next, another example. So this is one of the board exam problems last May 2019. So given the following cross-section notes for a road grading work, so these are the notes, and then the road bed is 9 meters wide, and the side slope for cut is 1 is to 1, and for fill is 1.5 is to 1. Determine the areas in square meters of the cut and fill of the section respectively. So again, you first plot the road, which is 9 meters. So we draw nimo 9 meters. Divide them. You draw a center line. So half is 4.5 and half is 4.5. So i-plot na to ni siya nga mga points. So where the 0 is, that's where the center line. So you can see X ang nasa ubos and these are the Y distances ng nasa taas or vertical distances. So 0 and then plus 1.2. So this point on this side, you can see x1. So that's x1 and negative 3.2. So if negative siya, that means that's below the road. So if this is a road, so negative 3.2 paubos. So this point, that is the x1 and negative 3.2. So on this side, so we have 3.5 and plus 1.2. So 3.5 and then plus 1.2. And then this one, x2 and plus 2.8. So x2 and plus 2.8. So this point. Again, how are we going to connect that? Start with the side of the road. So start with the road. Connect ni mo na siya. So you start with kani, kung saan, asa ni siya nga point, then kani, then kana. Then close it, going back to the side of the road. So from here, you connect this point, then connect at this point, connect at this point, connect at this point, and close it, going back to the road. So this is the cross-section profile. So with that, if this is the road and this is the profile of the ground or the soil, so that means kaning part, this area 1, that is the area to be filled. So na para makabutang ta sa road, that is to be filled. And then this part, area 2, 3, and 4, those are the areas to be cut. So, cut na siya nga soil profile. Okay. So, okay, so we have the side, the side slope for fill. This is the fill side. So that is 1.5 is to 1. So that will be 1.5 horizontal and 1 vertical. Again, kung unsay mas dako and it's not specified which is vertical and horizontal, kung unsay mas dako, that is the horizontal for the slope. So 1.5 horizontal and 1 vertical. So with that slope, and we have 3.2 here, we can solve for this distance. So that is 4.8. And then on the other side, so the side slope for cut, so this is the cut, 1 is to 1. Okay, we have 2.8 here, so that means this distance is also 2.8. And with that, we can solve for x2, it's 4.5 plus 2.8, so 7.3. And then this distance, this distance and this distance, we can solve that. Let's call this z. So z is to 1.2 for this triangle. Z over 1.2 is equals to 9.3 kanitanan. 9.3, I mean this one na day. 9.3 minus z, so kanilang it's 9.3 minus z over 3.2. So kaninga slope. So we can solve for z. Z is 2.536. So if z is 2.536, so this is 9.3 minus z. So this is 6.764. Okay, so now we have those dimensions. We can solve for the area. So area 1, this area, that is 1 half, kani 6.764 minus 4.8, so kani times 3.2. So that's 3.142 square meters. Area 2, so this one, that's 1 half, 2.536 times 1.2. So it's 1.522 square meters. And area 3, so this area, that's 3.5 times 1.2. So that is 4.2 square meters. And area 4, so area 4 is kani then minus na to niya triangle. So it's 1 half, 1.2 plus 2.8 times 7.3 minus 3.5. Kani. Minus this triangle, that is just 1 half, 2.8 times 2.8. So area 4 is 3.68 square meters. So the area cut, so areas to be cut, those are area 2, 3, and 4. So you add areas 2, 3, and 4, it's 9.402 square meters. And area fill, so this area, that's area 1. So area 1 is 3.142 square meters. Okay, so let's proceed. So cut and fill. Okay, so if you have here from station N to station N plus 1, you have your ground profile, then G, that is grade of the ground. So this one, and then if you are to make a road here, then you have GR, that's the grade of the road. So if you're going to make a road there, so that means kaninga part that is to be filled. So H fill, that's height to be filled. And then this part that is to be cut or to be excavated. So this is the height to be cut. So one is yeah. So okay, so we can form a triangle here. Kani straight lang na to ang road. Straight lang to ang road ay ang ground. So kaning broken line. That's the grade of the road, grade of the ground. Yeah, grade of the ground. And then this is the road. So if ato na siyang i-draw this yellow line just parallel to the grade of the road. So ato siyang i-draw diha to form this triangle. This is just the same H fill with this H fill since parallel ra sila. And this is the H cut. Okay, so this is the length fill and this is the length cut. Okay, so kanina triangle. So you have this triangle where this is H fill plus H cut. And then this is the total length. So with that, you have this height, that is the grade of the ground times L. And this height, that is the grade of the road times L. It's GR times L. Okay. So, dire makita nimo, this is station N, this is station N plus 1. And this is the road. If straight na to, that's the road nga i-construct. And this is uh, the earth to be filled, and this is the earth to be cut. So you have a formula here, L times grade of ground minus grade of road. That's equals to height fill minus height cut. Or length is grade of road minus grade of ground equals H fill plus H cut. So since nganong duha man na siya, what you're going to do is kung unsay positive sa grade of ground and grade of road, is mo na siya mo unahon. So if positive ang grade of ground, so muna siya unahon minus the grade of road. If positive ang grade of road, so you have their grade of road minus the grade of ground. Okay. So let's proceed. So mo ni siya ang uh, section. So it's the fill and cut. Okay. So let's have an example. So the ground makes a uniform slope of 4.8% from station 12,000 plus 180 to station 12,000 plus 250. So kani, let's draw the station 12,180 and here is 12,000 plus 250. So from this station to this station, you have the ground with a grade of 4.8%. So positive, so that means pasaka itong ground dire. Okay na siya. At station 12,000 plus 180. So here, the center height of the roadway is 1.3 meters fill. So from the ground, netong ground. 1.3 meters fill. So na diri atong road. So this is part to be filled. At the other station, so diri, the center height is 3.5 meters cut. So from the ground, we need to cut 3.5 meters. So muna siya tong road. So muna siya ang fill and cut. So find the grade of the finished road. So again, ato siyang i-parallel, i-draw na to parallel diri. Like parehara diri. So kana ato ang grade of the road. This is the same H fill, that's also 1.3. So solution L, so this distance, so that's just subtract na nimo ang station. It's 12,250 minus 12,180. So that is 70 meters. So that's L. L, so unsa may itong unahon, which is positive, that is the grade of ground. So L is times grade of ground minus grade of road. Then equals to H fill plus H cut. So L is 70 times the grade of the ground is 0.048 minus the grade of road. So equals 1.3 plus 3.5. So you can solve for the grade of road, that's negative 0.021 or negative 2.075%. So that's the grade of road. Another, another. From station A with a center height of 14 meters fill. So you draw station A and station B. Then for 1.4 meters fill, so that means from the ground, if you have your ground here at station A, you have to fill 1.4 meters. So 1.4 meters. The ground has a uniform slope of 5% to station B. So this is the grade of the ground. It's 5% from A to B, whose center height is 2.8 meters in cut. So at station B, this is our ground at this point. So we have to cut 2.8 meters. So muna siya to ang road. Assuming both section to be level sections, level section has so kana straight. Having a width of 14 meters, so that is the road width. And side slope of 2 is to 1 for both cut and fill. Compute the cross-sectional area of cut, 52 meters from station A. So distance between station A and B is 60. So from A to B, that's L, that's 60. Then 52 meters from station A, so that is somewhere here. So natunong jud siya sa cut na section. So find the cross-sectional area at this point. So that is the earth to be cut. Okay. So we have here solution. This is a similar triangle. Kana siya, this triangle, and this triangle. Kana. So y plus 1.4, kani y plus 1.4, and then distance from A is 52. Equals, this is 1.4 plus 2.8, kani, and the distance from A, that's 60. So you can solve for y. Y is 2.24 meters. And this is our section for the cut diri, 52 meters from A, and that's y. So 14, that's where our road width, 14, and then y muna siya dire, is y, and then uh, call this distance x. So assume this is symmetrical, so that's x, and the side slope, that's 2 is to 1, so 2 horizontal and 1 vertical. Okay, you can solve for x, that is equals to 2y. So x is 4.48 meters. So the area of the section for cut, So that is 14 times y. Kaning sa tunga niya, if you're going to draw a square or a rectangle, that's 14y plus 1 half xy times 2. So you can cancel the 2, so that's just x times y. So that's 4.48 times 2.24. So the area is 41.395 square meters. Okay. So next here we have regular areas. Okay. So if you have here kaning areas, this area to be solved or to calculate, then they are divided by the same distance d. So same na silang distance d, but different height. You have h1, h2, h3, h4, h5, h6, and h7. So using trapezoidal rule, area is d over 2 h1 plus summation of plus 2 times summation of hm. So those are the height in the middle, h2 to h6, plus hn, that is the last height, that's h7 for this example or this figure. Then Simpson's one-third rule, area is d over 3 times h1 plus 2 times summation of h odd. So h odd, those are h3, h5 for this figure. Anang between lang sa tunga nga odd. Then plus 4 times summation of h even. So that's h2, h4, and h6 for this figure. Kanang sa tunga lang ha even. And plus hn, so hn is the last height, that's h7. Then we have volume of earthworks. So using end area method, so you have volume of earthworks PE is equals to L over 2 area 1 plus area 2. So if you have here this earthworks, you have area 1 and area 2, and you have a length between them. So using end area method, so this is how you solve L over 2 area 1 plus area 2. Using Prismoidal formula, the volume is L over 6 times area 1 plus 4 times area middle, this area, plus area 2, so this area. So volume of earthworks, Prismoidal correction formula. So correction, volume correction, that is L over 12 times C1 minus C2 times D1 minus D2. And the volume corrected, that is V equals VE plus minus C volume or correction sa volume. So, if you have here, this is your VE, di ba? Solve kag VE kani, VE. And then, subtract the correction sa volume. That's L over 12. This is the same L kani nga L. L over 12. C1 minus C2. So, for example, this area, sa area 1, you have C. Kani. This is the height sa center line. So, that's C. C1 is the C diri sa area 1 and C2 is diri sa area 2 nga C. It's C1 minus C2. D1 minus D2. D1 is kani D is distance sa imuhang section. So D1 is the D diri sa area 1 and D2 is the area diri sa area 2. I mean the D diri sa area 2. D2. So that is C1 and the D. So let's have an example. Okay. So the areas in cut of two irregular sections, 75 meters apart, are 36 square meters and 52 square meters respectively. Base width is 10 meters, side slope is 3 horizontal and 2 vertical. Using prismoidal corrections formula, find the corrected volume of cut in cubic meters between the two stations. So, this is our section. So, wala man siya gi-state. So, we have to assume this is a level section. So, 75 and 36. And then, distance between them is 75. So, niingon man siya og it is to be cut. So, the road is na dire below sa ground. 10 meters ang width sa atong road. Then that's 75 meters. So, this is the volume to be cut. And then on the sides, yeah, sa yung mga side slope. So, we are given here the side slope 3 horizontal and 2 vertical. So, this is the section at 36 square meters nga area. And then this one sa 72 square meters nga area. So you have the 10 meters width of the base. Then the side slope 3 is to 2. It's 3 is to 2. So let's call this X. So you have C1 and D1. Then at the 72 square meters, so you have 10 gihapon na siya. This is X. Let's call that X. Side slope is still 3 is to 2. Then this is C2 and this is D2. So solution. Area of this. So area is just 10 times C1 kaning sa tunga. 10 times C1 plus duha ka triangle on both kilid. Sa 1/2, that's X times C1 times 2 kay duha man both kilid. So X, this one, X, and this is in terms of C1. So na C1 man na siya dire. So X in terms of C1, you have the slope. X is 3 over 2 C1. Going back dire, area is 36. So that's equals to 10 times C1 plus makancel running 1/2 and 2. So you have X times C1. X is 3 over 2 C1 times C1. So C1 is 2.592 meters. And D1, that is 10 plus 2x. That's 10 plus duha ka 3 over 2 times C1. So we have C1, we have solved for C1. So D1 is 17.776 meters. And then here, area 2. So that is 10 times C2 plus 1/2 x times C2 times 2. So parehara na din eh. That's the center area plus the duha ka triangle on both gilid. Again, x in terms of C2 for this one, it's also 3 over 2 C2. So area is 72 equals 10 times C2 plus, again, makancel ra ang 1/2 and 2. So that's just x times C2. So 3 over 2 C2 times C2. And we can solve for C2, that is 4.355 meters. And D2, so that's 10 plus 2x. So 10 plus duha ka 3 over 2 C2. We'll have C2 solved. So D2 is 23.065 meters. Okay, go. Okay, so solving for volume of Earth. So L over 2, A1 plus A2. So L is 72 over 2, area 136 plus area 272. So volume of Earth is 4,050 cubic meter. So correction volume. So that's L over 12, C1 minus C2, D1 minus D2. So 75 over 12 times 2.592 minus 4.355 times 17.776 minus 23.065. So correction volume, that's 58.278 cubic meter. So volume corrected, so that's volume of earth minus corrected volume minus the volume correction. So V is now 3,991.72 cubic meter. Okay, so next, okay, volume of earthworks. So this one is panaog, muraog ka ng mga sa reservoir. So this one, you have different areas also. Different areas, area 1, area 2, area 3, hangtod area 7. And then with this the same or equal distance between them. So you have the trapezoidal rule. So trapezoidal rule, you have V is equals to D over 2, area 1 plus 2 area middle. So those are all the areas A2 to A6 plus area N, the last area 7. Then you have the Simpson's one-third rule method, or this is also called the prismoidal formula. So using Simpson's one-third or prismoidal formula, volume is equals to D over 3 times A1 plus 2 times summation of area odd. So odd areas between sa areas. So that's area 3 and area 5 plus summation plus 4 times summation of area even. So that's area 2, 4, and 6 plus AN. So that's the last area, that's area 7. Now this Simpson's one-third rule method or prismoidal formula, this can only be used if your areas are even. I mean add. So area 7. So area add ng last nga area. So like A7. Now if this is even, you have to add na add ano. So for example, we have example to na makita na to kung unsay buhaton or unsay may tabo if the area are even. So here, for example, the area bounded by the water line of a lake and contours a 2-meter interval are as follows. So you have area 1, 25,300 square meters. Area 2, 22,100 square meters. Area 3, 19,600 square meters. Area 4, 17,400 square meters. Area 5, 15,200 square meters. Area 6, 12,300 square meters. Area 7, 9,600 square meters. So 7 areas. So estimate the volume of water in lake in cubic meters using Prismoidal formula, and estimate the volume of water in lake in cubic meter gyapon using end area formula. Okay. So you have here sa solution. So the solution, okay, for the solution, so you have the distance, that's 2 meters, and then the area from area 1 to area 7. So you have there. And then, so using the Prismoidal formula. So using the Prismoidal formula, you have V is D over 3, A1 plus 2 times summation of area add plus 4 times summation of area even plus AN. So area 1 is the 25,300 square meters. Summation of area add, so those are area 3 and area 5. So that's 19,600 plus 15,200. So 34,800 square meters. Summation of area even. So area even is area 2, area 4, and area 6. So 22,100 plus 17,400 plus 12,300. So summation of area even is 51,800 square meters. And AN is area 7, 9,600 square meters. So the volume is D over 3, 25,300 plus 2 times 34,800 plus 4 times 51,800 plus 600. So volume using Prismoidal formula is 207,800 cubic meters. And then using trapezoidal rule, so volume is T over 2, area 1 plus 2 summation of area M plus area N. Area 1 is 25,300 square meters. Area N is area 7, 9,600 square meters. Summation of area M is area 1 plus area 3 plus area 4 plus area 5 plus area 6. So you add those areas, you have 86,600 square meters. So volume using trapezoidal rule, D over 2, 25,300 plus 2 times 86,600 plus 9,600. So 208,100 cubic meters. Okay, so dito na siya no, gamit sa formula if it is odd. Now, if it is even, okay, so for example here, we add area 8, which is 1,000 square meters. So the same lang ni sila from area 7, area 1 to area 7 sa previous, we just add area 8, which is 1,000 square meters. So we have here area 8, 1,000 square meters. Okay, now for the Prismoidal formula or Simpson's one-third rule. So what you will do, the volume will now be equals to D over 3 area 1 plus 2 summation of area add plus 4 summation of area even plus area n plus D over 2, that is the last odd area plus the last even area, plus area 7 plus area 8. Now our okay, so our area 1, so that is still the 25,300 square meters. Summation of area add. Summation of area add is A3 plus A5 ra gihapon. So wala ma-add ang area 7. Area 3 plus area 5 lang gihapon. So 19,600 plus 15,200. So you have 34,800 square meters for area add. For summation of area even, so you have area 2, area 4, and area 6. That's 51,800 square meters. Your area N is still the last odd area, that is area 7. So area N is A7, 9,600 square meters. So the volume is now D over 3, 25,300 plus 2 times 34,800 plus 4 times 51,800 plus 9,600 plus D over 2, 9,600 times I plus 1,000. So the volume using Prismoidal or Simpson's one-third rule is 218,400 cubic meters. And then for trapezoidal rule, just the same method apply. So D over 2, area 1 plus 2, summation of area M plus AN. So area 1 is 25,300 square meters. Area N is now area 8, that's 1,000 square meters. Area M is you add the area from area 2 to area 7, that's 96,200 square meters. So volume is D over 2, 25,300 plus 2 times 96,200 plus 1,000. So the area is 218,700 square cubic meters. Okay, so ang naalay ma-change or malahi sa formula is the Prismoidal or the Simpson's one-third rule when it is even or odd ang number of areas. Okay. So, bantayin na ninyo. Take note of that. So, let's have our last unit area method. Okay, so unit area method. So, assembly of rectangular prisms. So, you have volume is equals to area times summation of H1 plus 2 summation of H2 plus 3 summation of H3 plus 4 summation of H4 over 4. So, where H1, so you have here overall Earth, kana siya, divided into equal squares. So those they have equal areas na squares. And then each one is height found on one area only. So kaning gagmay nga squares, you have each one is found on one area only. So kana siya ana ra siya nga height, kani siya is ani ra pud siya nga area nga height. So kani sila mo na siya ang H1. H2 is height common to two areas. So H2 is kanang nay duha ka adjacent na area, then nay height between nila. Nga ana siya common siya sa duha ka area. So kana siya ang H2, kana sila H3 height common to three areas. So this one is H3 that is common to this area, and this area. So that's H3. H4 is height common to four areas. So kana mga nasa sud, yeah. So that H4 common na siya sa these four areas around it. So that's H4, height common to four areas. So let's have an example. So a 90 by 90 meters barrow pit is divided into 9 square sections. The following area are the elevations of the ground surface at the corners of each square section of the barrow pit. Barrow pit. Question? May question?
None, ma'am.
Miss Alaria, you have a question? Okay. So Okay, so the following elevations of the ground surface at the corners of each square section of the barrow pit. Barrow pit. Okay, so find the volume of earth to be excavated in cubic meters. If the ground surface is to be level to elevation 8 meters below the elevation 0. So kani hatagan ka og ingan ni. So this is the 90 by 90 barrow. Then they are divided into 9 equal squares. So they are equal areas. And then those numbers, those are the elevation at those corners or at those points. So those are the elevation. And then it says nga the ground is to be leveled to elevation 8 meters below the elevation 0. So you have this a 3D illustration. So kaning yellow line, that is the elevation 0. So kana nagsugod ning kaning nga mga numbers, 0 pasak that's 2.3 nga na. But below that, including pa ni siya sa i-excavate. So below 8 meters from that elevation. So you have this elevation negative 8. Okay, so you have the formula here for the volume. Summation of H1. So summation of H1, height common to one area. So kani sila 2.3 plus 2.8 plus 5.5 plus 3.8. So it's 14.4 meters. Summation of H2, height common to two areas. So this one, 3.1 plus 2.7 plus 3.6 plus 4.2 plus 4.8 plus 4.2 plus 2.8 plus 2 is 27.4 meters. Summation of H3, now if it looks like this, square lang siya, there's no H3. So 0. Summation of H4, so common to 4 areas, kay nasa sud. 1.8 plus 2.9 plus 3.4 plus 2.5. So that's 10.6 meters. So the volume, using this area of those small squares, that's 30 by 30. So 30 squared times 14.4, that's H1, plus 2 times 27.4 SH2 plus 3 times 0 plus 4 times 10.6. Oh, excuse me. Over 4. Over 4 plus kani, don't forget kaning nga sa ubos, apil pa na siya. That is 90 by 90. 90 squared times the height of 8. So the volume is 89,910 cubic meters. Okay. So last example. So the volume of a burrow pit is 90 meters by 90 meters is to be determined by unit area method. So the area is divided by equal square areas 30 meters by 30 meters. The height in meters of earth in each unit area are as follows. So dito na siya na row 1, row 2, row 3, row 4. So find the volume of the burrow pit in cubic meters. Unsa man ni pasabutan ni. So kani jitso na ni siya, muna ni ang mga elevation at the corners. So row 1 meaning kani that's kani elevation diri, kana upat ka elevation diha. Row 2 this elevation diri, upat ka buok. So kana. And row 3 kani nga mga elevations, kana upat. And row 4 this elevations, kanang upat. And dito na na siya. So ayan ni ang pasabot niya ni ang porma na. Then, mo na ni ang elevation. So again, summation of area H1, summation of H1, so those are 3.2 plus 4.2 plus 2.6 plus 3 is 13 meters. Summation of H2, that's 2.8 plus 3.6 plus 3.8 plus 3 plus 2.8 plus 2.5 plus 3.1 plus 3.8 is 25.4 meters. Summation of H3 is 0. Summation of H4 plus 2.5 plus 3.2 plus 3.3 plus 2.9. So that's 11.9 meters. So the area is still 30 by 30. That's the equal square areas. So 30 by 30 is 900 square meters. And then the formula for the volume. So you have here volume is equals to 900 times 13 plus 2 times H2 25.4 plus 3 times H3 0 plus 4 times H4 11.9 meters over 4. So the volume is 25,065 cubic meters. Okay, so on na siya. Okay, so if you have a question, you can ask your question. And also, as I have posted in the Google Classroom, after this, next week, after the holidays, we'll have a quiz on this topic. So next week, we will have a quiz. Okay, so just review those notes. Okay, so if you do not have questions, please turn